Hello, everyone. My name is Jefferson Ortega, and today I'm going to be presenting the Video-Based Emotion and Affect Tracking in Context Dataset, or the VEATIC dataset. I wanted to start off by asking you what you think this woman is feeling. You might think that she's feeling shocked, or maybe even surprised, or even sad. And these are all guesses that you're making based on face information only. But what if I told you these guesses are actually wrong? If we see the face in context, we realize that this woman just won a prize. So she's actually very happy or ecstatic. And that is the correct guess. This is just one example, but it shows how context is incredibly important for emotion perception. And then when we only have access to facial information, we can actually come to the wrong assumptions about other people's emotions. Many computer vision data sets have been created to try and assess the emotion of people. But a lot of these data sets are face-centric, meaning that they only focus on facial information. And as we saw previously, the context is incredibly important for emotion perception. Some example data sets are the VEATIC2024 dataset, which only includes facial information. It has no context. And it also has no dynamic information. Dynamic information is important because context isn't just about spatial context, but it's also about temporal context. There is the SEND dataset, which does incorporate temporal context, right? So it includes videos, but there is no context, no spatial context in this dataset. There are more in the wild datasets, which try to incorporate context into the datasets, like the emotic dataset, which does include contextual information, but it includes no dynamic information. So usually these ratings for these datasets or the stimuli used in these datasets are static frames and not videos. Finally, there's also the CARE dataset, which does include dynamic information. It does include context, but usually it's in very short clips. So the clips in the CARE dataset are usually from 2 to 10 seconds long. However, when humans perceive emotion in the real world, it's not usually for 2 to 10 seconds, it's usually for long periods of time. Thus, in this presentation, we are presenting the VEATIC dataset, the video-based emotion and affect tracking in context dataset. And this is an example video from our dataset. In this video, observers are tasked with inferring the emotion of this lady while she's on this roller coaster. As you can see, there is context, there's spatial context, right? The woman's in the roller coaster. There's also temporal context, and these are long videos. As you can see, the video is still going. And what observers do is they actually track the emotion using a 2D rating grid that tracks the emotion of the character in terms of balance, or negative and positive emotions, and arousal, or how intense an emotion is. And this grid here just shows an example of the rating in real time. You can see that it starts off as positive, and as the roller coaster keeps going, you can see that the rating becomes more high arousal as the intensity of the emotion increases. This is an example of the same rating, but in 2D space. On the y-axis, we have the arousal rating or the intensity of the emotion. On the x-axis, we have time. And the color of the rating is based on the valence, or how negative and positive the emotion is. As you can see, it starts off a bit negative. The lady seems not very happy of being on the roller coaster ride. Then seems to kind of enjoy it. And then near the end, she becomes very terrified. And so you can see that it becomes very red. This is just one example of one of the videos in our data set. However, we have many different kinds of videos, which include documentaries. And these are videos that show candid expressions. So there's no acting in these videos, but there's some form of video editing. We also have home videos, and home videos are, again, candid social interactions or social videos with no video editing. And then there's Hollywood movies that, of course, have acting and have some form of video editing. Again, these are just 3 new examples, but in total, the VEATIC dataset actually has 124 different videos. These are some extra examples here. And we show a few more examples on our poster that is posted on the WACV website. This is just, again, a new example of the dynamic nature of emotion perception in another video in our dataset. The frames up here correspond to different points on this graph here, and they're color-coded. So you can see the target character here is actually this woman seated back here. And she seems very calm and relaxed in the beginning. And you can see that the arousal shows that. The arousal is low, and then it turns red. as this woman becomes agitated. And it keeps being red until she's actually upgraded to first class. You can see the flight attendant bringing a turkey to the lady, and now she's actually very happy, as shown in the green line here. The VEATIC dataset also has emotion ratings for multiple characters in a scene. When humans perceive emotion in the real world, they usually don't just track the emotion of a single person, but they also track the emotion of multiple people while they're having social interactions. Thus, the VEATIC dataset actually has ratings for one character in a scene and also another character in a scene. So computer vision models can be trained to accurately infer the emotion of different characters in the same scene. Some dataset statistics of the VEATIC dataset. We have a total of 192 annotators, an average number of annotators of 60 per video, and the range of our videos are from 10 seconds to 2 minutes and 30 seconds. So we have a lot of annotators annotating these videos, and they're also long videos, not short videos. This figure here shows the distribution of the valence and arousal ratings in our video. As you can see, the ratings in the VEATIC dataset actually encompass the wide range of valence and arousal rating space, as shown in the distributions here and here. And the dots that you're seeing on this figure are actually the average rating of all the videos in the dataset. And they're identified by the circle, square, and triangle for Hollywood movies, documentaries, and home videos. We also measured the familiarity and enjoyment of annotators while they were watching the video clips. And annotators had a low familiarity and a moderate enjoyment while annotating the video clips. Finally, we look at how having more annotators leads to a lower standard deviation in the data. Most data sets for computer vision have only around 5 annotators, which can lead to very inaccurate ratings. Here we show the standard deviation of the ratings when you only have 5 annotators. As you can see, it's very high. And when we include all the annotators in the VEATIC dataset, the standard deviation actually shrinks, goes lower, and shows that when you have more annotators, you can get closer to the ground truth than when you only have 5 annotators, which makes computer vision models more accurate at inferring emotion, or at least real emotion. We also propose a simple baseline model to benchmark the new emotion recognition in context task, to infer the valence and arousal of the selected character via both context and character information in each of the video frames. We adopted 2 simple sub-modules, a convolutional neural network module for feature extraction, and a visual transformer module for temporal information processing. At last, the prediction of arousal and valence is accomplished by a multi-layer perceptron head. We benchmarked the new emotion recognition in context task using these 4 metrics: concordance correlation, Pearson correlation, root mean square error, and sign agreement. Compared to other datasets, our proposed simple method is on par with state-of-the-art methods on their datasets. We also investigate the importance of context and character information in emotion recognition tasks by feeding the context-only and character-only frames into the pre-trained model on fully informed trains. Fully informed frames just means that it shows all the information available in the frame. Character only has the target character in the frame, and context only has everything in the context, but not the target character in the frame. In order to obtain fair comparisons and exclude the influence of frame pixel distribution differences, we also fine-tuned the pre-trained model on the context-only and character-only frames. We can see without the full information, the module performance drops for both context-only and character-only conditions. In order to show the effectiveness of the VEATIC dataset, we utilized our pre-trained model on VEATIC, fine-tuned it on other datasets, like the Emotic and CARE dataset, and then tested its performance. Our pre-trained model performs on par with the proposed methods in Emotic and CARE. Thus, it shows the effectiveness of our proposed VEATIC dataset. We'd like to end by acknowledging the Whitney Lab and our collaborators, as well as the research assistants who helped collect this data. Finally, you can access our VEATIC dataset using this QR code here. Thank you.